Picture a cosmic orchestra composed of countless stars, planets, and moons, all producing a symphony in flawless coordination. Yet there's one part of this heavenly music that has baffled astronomers for centuries: exoplanets. Exoplanets are natural planets located beyond our solar system, tucked away within the vast expanse of the Milky Way. Within the vast array of cosmic bodies, you might be surprised to learn that some exoplanets are so remarkably similar to Earth, so closely resembling our own planet, that they could be visible as its twin in the heavens. Let's explore the captivating world of Proxima B, just a mere 4.2 light-years away. The James Webb Space Telescope is revolutionizing our comprehension of these cosmic wonders, pushing the boundaries of exploration and providing us with new insights into these celestial bodies far away. Picture your thoughts wandering through the expansive reaches of our galaxy, the Milky Way, home to an astonishing number of exoplanets. There are so many that their total number could be further out in the quintillions, beyond human comprehension. To put this into perspective, if each exoplanet were the size of a grain of sand, they would not only fill the Grand Canyon, but we could construct an entirely new geological wonder on Earth. An expansive Grand Canyon 2.0 that extends for miles. The most striking statistic is that 20% of these planets are considered to be Earth-like, showing similarities in geologic and atmospheric composition. This means there is a chance, 1 in 5, of finding a planet that could resemble our own. But the narrative does not end there. Around these planets, there could be another quadrillion moons, rocky satellites similar to our own moon, doing intricate gravitational dances with their parent planets. With so many possibilities in the vast cosmos, the prospect of finding a world that could harbor life gets more tempting as each discovery progresses. The immense scale of the universe demands an ultimate tool to explore it: the James Webb Space Telescope. This celestial detective, often likened to a space-age Sherlock Holmes, uses its massive primary mirror, 6.5 meters across, much larger than Hubble's, to record specifics from distant stars billions of light-years away. The telescope's unprecedented ability to observe and analyze celestial objects allows it to detect the faintest light and reveal intricate details of orbiting planets. What sets the James Webb Space Telescope apart is its technological sophistication, including advanced sensors and spectrographs. These tools go much further than just observing objects in space. They can decipher the distinctive light patterns released or reflected by these celestial bodies, offering information about their atmospheric conditions, composition, density, and even their mass. Essentially, it functions like a forensic investigator of space, determining whether a planet could harbor water, organic compounds, or even oxygen. This breakthrough advances our understanding far beyond what was achieved with the Hubble telescope. While Hubble's discoveries were remarkable, the Webb telescope represents a quantum leap in space exploration, giving us the ability to dive deeper into the mysteries of the cosmos. One particularly intriguing object in this vast universe is Proxima B, a sphere that has attracted the attention of scientists since its discovery in 2016. Just 4.2 light-years away from Earth, Proxima B is in our immediate cosmic neighborhood, a proximity that is crucial in the grand scale of a universe stretching 93 billion light-years. To put it simply, finding a planet so close to Earth with such scientific potential is like stumbling upon a rare gem in a mountain of diamonds. What makes Proxima B so captivating is not just its distance from Earth, but the tantalizing possibility that it might be Earth 2.0. Proxima B resides in the habitable zone of its parent star, where the temperature is neither too hot nor too cold, making it an ideal candidate for liquid water to exist. Picture rivers, lakes, and oceans overflowing with potential life. But before we get too excited about a vacation on this distant world, there are some curious aspects to consider. For example, one day on Proxima B lasts an incredible 11 Earth days. Imagine sunrises that seem to stretch for hours, golden sunsets that last forever, and lighting conditions photographers dream about. While this might sound picturesque, it has important repercussions for its climate and habitability. How would life on Proxima B endure such extended periods of light and darkness? Would humans need to adjust their eating and sleeping habits to match the planet's unique day cycles? At night, the rhythms of life as we know them would be both familiar and strange, posing a riddle about what makes a planet truly habitable. With this in mind, you may wonder how we could possibly collect reliable information about a planet we've never set foot on. The answer lies in the James Webb Space Telescope. More than just a telescope, it acts as a multifaceted space laboratory, equipped with cutting-edge tools to analyze distant exoplanets in great detail. Utilizing advanced spectrographs, light that is reflected or emitted by distant planets can be broken down so that their atmospheres can be examined, revealing their composition, pressure, and even the presence of vital compounds for life such as water, organic carbon molecules, and oxygen. This space forensics offers insights into these otherworldly planets. By studying the light they emit, the James Webb Space Telescope is more than just a cosmic observer. It's a cosmic detective, providing the means to either confirm or disprove our hypotheses about the potential for life on distant planets. By turning speculative ideas into scientific inquiries, it revolutionizes our understanding of what might exist beyond Earth. Then, just as we thought we had uncovered all the mysteries, an unexpected turn occurred. Researchers at the James Webb Space Telescope detected an unusual signal emanating from Proxima B, an electromagnetic emission that appeared to be so structured and intricate that it sparked heated debates. Could this signal be evidence of an advanced civilization? For a brief moment, the entire world held its breath, wondering if this could be the breakthrough confirming that we are not alone in the universe. But just as quickly as it appeared, the signal disappeared, leaving behind a smattering of unanswered questions. Was it a transient anomaly or perhaps something far more deliberate, a message or a sign of an advanced extraterrestrial presence? The origin of this signal is still up for discussion. It continues to stir excitement, fueling theories and speculations. The incident casts a mysterious shadow that hangs over Proxima B, but also opens up possibilities for future discoveries. Was this an isolated incident, or is it part of a much larger cosmic story? Time will tell. However, the search for extraterrestrial life is far from over. A new wave of researchers, including Harvard students, are expanding our search. They are transforming the James Webb Space Telescope into a cosmic night vision instrument aimed at detecting artificial lighting on distant worlds. Imagine witnessing glowing cities on other planets, emitting signs of advanced civilizations. The implications of such a discovery would be staggering, altering our understanding of life in the cosmos. As the search for life on other planets continues well beyond Proxima B, advances in space exploration. Each new technological leap brings us closer to uncovering the truths hidden within the vastness of space. With every exoplanet discovered, and every signal detected, our understanding of the cosmos evolves, redefining not only our place within the universe but also the potential for connection beyond it. Consider, for a moment, the emotional impact of such a discovery. The confirmation of life, or intelligent life, on another planet would ripple through every facet of human existence. Philosophy, religion, science, culture, even our daily conversations, would undergo profound shifts. The solitude we've long assumed might give way to something far greater, cosmic companionship. This is why the search continues with relentless energy. From the icy moons of our own solar system, like Europa and Enceladus, to the warm, Earth-like exoplanets orbiting distant stars, we scan the skies not just with instruments but with hope. Hope that somewhere, among the trillions of possibilities, we are not alone. In the coming decades, missions will not only observe from afar but aim to sample, land, and possibly return materials from exoplanets or their moons. Concepts for interstellar probes, like Breakthrough Starshot, are being developed to one day reach Proxima B and send back data, not in centuries, but in decades. The idea of visiting another world is no longer the stuff of science fiction. It is becoming a scientific trajectory, fueled by curiosity, advanced by technology, and driven by the age-old question that has haunted humanity since the dawn of time. Is there someone out there, looking up at their night sky, wondering the same about us? Until that day comes, the James Webb Space Telescope continues to scan the heavens, unlocking secrets etched in starlight, one photon at a time. Behind every data point lies a whisper from the cosmos, a potential greeting, a mystery, a story yet untold. The search is not just about finding life, it's about understanding life itself. Our comprehension of life and our location, as we continue our journey in the cosmos, opens up the possibility of discovering novel forms of life and expanding our knowledge. The quest to discover the limitless universe helps us comprehend that life beyond Earth is not merely a pursuit of discovering alien civilizations. It is an investigation into the very essence of existence as a whole. By searching for biosignatures, traces of life in the chemical makeup of distant planets, we also learn more about potential ancestors and the variety of life that could exist across the universe. This quest invites us to re-examine the conditions required for life to thrive beyond our capabilities, to consider what we deem habitable, and to imagine extraordinary possibilities for life in environments so dissimilar to our own. The expanding capabilities of space exploration tools and our growing knowledge of exoplanets are helping us answer these questions with increasing precision. As we develop more sophisticated instruments and engage in international collaboration, our collective capacity to detect and study exoplanets becomes exponentially stronger. Tools like the James Webb Space Telescope and advanced ground-based telescopes offer unprecedented analysis of the atmospheres of exoplanets, uncovering potential indicators of life, whether advanced or microbial, that could exist there. As we continue to advance, one of the next great frontiers will be exploring the moons of distant exoplanets, just as moons in our solar system, like Europa and Enceladus, are considered prime candidates for harboring life in their subsurface oceans. The moons of exoplanets may offer similar opportunities for discovery. Especially those located in the habitable zones of their parent planets may have conditions that make life possible and present entirely new avenues of exploration that could hold the key to understanding life elsewhere in the universe. The hunt for technosignatures, evidence of advanced technologies, elevates this exploration to a new level. It introduces the possibility of recognizing artificial structures like megastructures or advanced communication systems. The search for these signs adds a new dimension to the ongoing investigation of intelligence from other planets, launching us into a future where the search for life is not just a question of biological survival but a matter of discovering beings that have developed sophisticated technologies similar to our own. Beyond just finding new forms of life, this exploration inspires profound questions regarding our position in the universe. Are we the only ones to have existed? Do other intelligent life forms exist that have evolved civilizations and struggled with challenges similar to our own? The possibility of connecting with another intelligent species, or simply gaining a greater comprehension of life's nature, presents a fantastic opportunity to enhance our collective understanding and redefine our view of life itself. The exploration of exoplanets, technosignatures, and biosignatures also carries significant implications for the future of humanity. It forces us to reconsider the fragility of our existence, the possible outcomes of expanding our reach into the stars, and the importance of safeguarding life on Earth. As we continue to uncover the mysteries of distant worlds, we must balance our scientific curiosity with the responsibility to protect the planet that has given us life. It is no longer just a matter of scientific discovery but also of deep philosophical inquiry. What would the discovery of alien life mean for humanity's sense of identity and purpose? Would we be humbled by our small place in the grand universe, or would it spark an entirely new chapter in human history, one filled with new hope and new challenges? With each new development, the discovery of a potentially habitable exoplanet, each unusual signal detected, and each biosignature analyzed, we come closer to understanding not only the possibility of life beyond Earth but also the origins of life itself. The revelations we uncover through the study of the cosmos are rewriting the narrative of our existence, reminding us that we belong to a vast, interconnected universe filled with possibilities beyond our wildest imaginations. The field of space exploration is ever-changing, and the possibilities increase with each step forward. As new telescopes are constructed and technology advances, our understanding of the universe will expand. Future missions and collaborations, in addition to the ongoing use of the James Webb Space Telescope, promise to continue providing new insights into the potential for life beyond our planet. During this exciting time of discovery, we stand at the precipice of something monumental. The search for extraterrestrial life is more than a scientific endeavor, it is an existential journey that asks fundamental questions about who we are, where we come from, and what the future of humanity might look like. In the end, when we keep pushing the limits of our understanding and explore the vast, undiscovered areas of space, we get closer to finding the answers to questions that have long piqued human curiosity. One day, life on other planets may reveal answers not only about extraterrestrial existence but also about our own ancestry and our place in the cosmos. With each discovery, we inch closer to understanding the profound mystery and incredible possibilities the universe presents. As we venture deeper into the cosmos, the potential for uncovering new realms of knowledge and understanding grows at an exponential rate. Technological strides made in space exploration are opening up new frontiers, enabling us to investigate the atmospheres, compositions, and even the climates of faraway exoplanets. Instruments like the James Webb Space Telescope have brought us closer to detecting crucial signatures that may indicate the presence of life. This includes examining not only atmospheric gases but also potential surface features and geological activity. The discovery of exoplanets and their habitability, particularly those in the habitable zone, has redefined what we consider suitable environments for life. While Earth-like moons are particularly interesting, planets orbiting these moons are becoming increasingly important in our search. Europa, a moon of Jupiter, has long been a prime candidate for harboring life due to its subsurface oceans. Moons in other solar systems may also harbor similar potential. Future missions will keep expanding on these discoveries, deepening our understanding not just of the fact that life may exist but also of the evolution of complex ecosystems across the universe. By studying exoplanets and their moons, we are not only uncovering the dark secrets of faraway worlds, but also learning about the fundamental processes that may govern life itself, wherever it may exist. As our journey into the cosmos continues, the questions grow deeper, more profound, and more personal. Each discovery forces us to reconsider not only what is possible but what it means to be human. The realization that life may exist elsewhere in the universe reshapes the boundaries of our understanding, expanding the scope of science, philosophy, and imagination alike. The implications stretch far beyond scientific curiosity. They touch the core of our identity, our purpose, and our future. If we discover that life is common in the universe, then perhaps we are part of a vast network of living systems, interconnected across time and space. If life is rare, then our responsibility to preserve and protect it becomes even greater. Either way, we are confronted with the urgency to steward our planet with care and to pursue our exploration with humility. Interdisciplinary efforts will become increasingly important. Astrobiologists, chemists, physicists, engineers, philosophers, and artists will all play a role in interpreting the meaning of what we find. This new age of discovery requires not just technical innovation, but emotional and intellectual openness. We must be prepared to embrace unfamiliar forms of life, consciousness, and communication, forms that may defy our expectations and challenge our worldview. We must also confront ethical questions. If we find life on another planet, do we have the right to interfere? Can we explore without disrupting ecosystems that may have evolved in complete isolation? What responsibilities will we have toward alien life, should we encounter it? These are no longer abstract questions, they are becoming real, immediate, and necessary to address. The universe invites us to grow not only in knowledge but in wisdom. As telescopes peer deeper into the fabric of space-time, capturing light from ancient stars and galaxies, we are not just learning about the cosmos, we are seeing a reflection of ourselves in its vastness. The same atoms that forged stars and planets also formed our bodies, our minds, our dreams. The story of the universe is, in many ways, the story of us. And so we continue, not just as explorers or scientists, but as seekers of meaning. Every signal, every discovery, every quiet whisper from the stars carries with it the potential to transform how we live, how we think, and how we love. The search for life beyond Earth may someday bring us face to face with the unknown. But in that moment, we may also come to better understand what it means to be alive, here, now, on this fragile blue planet, drifting in a sea of stars.